Okay, let's start with some PYQs of strength of material, solid mechanics. This chapter is properties of metal, stress and strain. So this first question, the stress strain diagram for two materials A and B is shown below. So you can see stress and strain diagram and material A and material B. So obviously by looking at this, what you can infer, the following statements are made based on this diagram. Material A is more brittle than material B, and second statement, the ultimate strength of material B is more than that of A. So individually we have to see the which statement is correct. So material A is more brittle, so that is true, right? Because you can see the graph, it is less ductile. Basically here you can see the strain value is more in material B, and material A is directly stress versus strain graph, you can see it is going higher. So its stress is more, so it can resist more stress. So that is material A is more brittle, that is true. Ultimate strength of material B is more than that of A. So that is wrong, because it is ultimate strength is more for A material, because the graph is higher as compared to graph of material B. So here the answer is C. Okay, then next question 1.2, the dimensions for the flexural rigidity of a beam element in MLT. So how you can solve flexural rigidity? Basically, see, you should know what is flexural rigidity. Flexural rigidity means EI. Okay, so E, you can write Newton per mm square, and I is mm raised to 4. So basically it will be Newton mm square. So Newton, how you can write? Newton is basically force, so force is mass into acceleration. Acceleration is L t raised to minus 2 meter per second square. So, and again mm square means length square. So answer in terms of MLT will be m L cube t raised to minus 2. So what is the answer? Yes, B is the answer, right? Another thing is another question, the shear modulus G, modulus of elasticity E, and Poisson's ratio mu of a material R. Okay, so sometimes they are giving Poisson's ratio as mu. Okay, so no problem. See, in many times they are asking direct questions based on formula. See, this was asked in 2002, but nowadays such type of questions are not asked. They will be giving some values in it, and we have to find the other parameters, right? So basically you have to remember the formulas. So just I will write down some of the formulas which are very important. Okay, so first formula I am writing, E is equal to 3k 1 minus 2 mu. Okay, we all know E is your Young's modulus, K is your bulk modulus, mu is your Poisson's ratio. What is Poisson's ratio? Poisson's ratio is your lateral strain upon longitudinal strain. ठीक है, बल्क मॉड्यूलस भी हमको पता है. बल्क मॉड्यूलस क्या है? स्ट्रेस अपॉन वॉल्यूमेट्रिक स्ट्रेन. ठीक है, सो सेकंड formula you can remember is E is equal to 2G 1 plus mu. Same way you can remember one more third formula, E is equal to 9 kg upon 3k plus G, and for Poisson's ratio mu is equal to 3k minus 2G upon 6k plus 2G, and one more formula you can memorize, that is mu is equal to 3k minus E upon 6k. Is it fine? So these 5 formulas if you memorize, you can solve any of the questions. Just you have to play with these parameters, right? Okay, then next question, I hope you can see. A bar of varying square cross section is loaded symmetrically as shown in the figure. Loads shown are placed on one of the axis of symmetry of cross section, ignoring self weight, the maximum tensile stress in Newton per mm square anywhere. Okay, so basically you can see they have given here the bar which is loaded by 50 kilonewton in the bottom portion, and the top portion is 100 mm, and it is having square cross section. So basically let's solve it. See what they have given, that I am showing. Just I will copy the question quickly. So this is, suppose this is 100 mm square cross section. This is your 50 mm cross section. Okay, here one load is 100 kilonewton, another load is hanging over here 100 kilonewton, right? Now the central load is 50 kilonewton here. Is it okay? So now I am supposed to find out the stress in both the parts. Suppose this is part 1 and this is part 2, right? In both the part, and whatever maximum stress, then that will be my answer. Okay, so I know the formula of stress is equal to force upon area, right? So for part 1, what is stress? Sigma is equal to force. How much force is total force? You can see 100 plus 50 means total is 250 kilonewton. So 250 into 1000. Okay, and area, this is square cross section, so 100 into 100, so this 3, this, so answer is 25 Newton per mm square for part 1. Here you have to check for part 2 also, because whichever is greater, that will be the answer. So sigma for part 2 will be total load is here only 50 kilonewton. Here you don't have to take 100 kilonewton because that is hanging on part 1. So here 50 into 1000, because kilonewton is to be converted into Newton, divided by what is the cross section area? 50 into 50, 0 0 0 0. Okay, 5. So sigma here you will get 20 Newton per mm square. Now obviously this is greater, so answer will be 25 Newton per mm square, right? So answer will be C. Now another question, for linear elastic system, the type of displacement function for strain energies. So what will be the answer? The answer will be linear, quadratic, cubic or quartic. So it is quadratic basically. See how it is quadratic? Simple, you have to remember what is the formula of strain energy. See here, strain energy is equal to half stress into strain, half sigma into epsilon, right? Now sigma is stress, epsilon is strain. So what is strain? Basically strain is delta L by L, that is epsilon. So you can see here that the strain is directly proportional to your delta L, means strain is directly proportional to your displacement, right? Now they have asked you regarding the strain energy. Okay, so in strain energy, how you can convert it? Strain, and see, we know that E is equal to sigma stress upon strain. So what is strain? Strain is sigma upon E. So put it in the value in this equation. So strain energy, basically strain energy will be half into, here I have to just cross multiply. Sigma is equal to E into epsilon. So E into epsilon into again epsilon. So it will be half E epsilon square. Okay, so here you can see strain energy is directly proportional to square of the strain. So square of the strain basically square of the displacement, hence it is in the form of quadratic equation, because here you are getting, because see here uh, E is Young's modulus. Okay, so here if we compare strain energy and strain, so strain energy is directly proportional to square of the strain, and that itself is directly proportional, strain is proportional to delta L. So here the question they have asked is the strain energy is the type of displacement function for strain energy is quadratic. Okay, next question is regarding the symmetry of stress tensor at a point in the body under equilibrium is obtained from. So see, you can see the options: conservation of mass, force equilibrium equations, moment equilibrium equations, conservation of energy. So what will be the answer? Basically the answer will be your moment equilibrium equation. How? Because see, here I am drawing one small block, you can see ABCD. Okay, and it is a square block. So suppose this is D, this is also D. Okay, suppose it is having direct tension, that is sigma x tensile forces, major principal stress you can say. Here also sigma y. Now if it is subjected to torque, shear stress. Okay, suppose it is subjected to a shear stress tau xy, and here also it will be tau xy in opposite direction. Here it will be tau yx, opposite direction tau yx. So just you have to take moment. If you take moment about this center O, okay, so let's see, this tau x, it is in clockwise direction, but the distance is how much? Half perpendicular distance. So tau xy into d by 2. So that is in clockwise direction. Here also tau xy will be in clockwise direction, plus tau xy into d by 2. Okay, this tau yx with respect to this point will be anti-clockwise. So minus tau yx into d by 2. Again this tau yx d by 2 minus is equal to 0. So if we simplify it, ultimately it will be 2 tau xy d by 2 is equal to 2 tau yx d by 2. So it will be tau xy is equal to tau yx. So basically it is, we can say, we can prove that it is moment equilibrium equations, right? Again this question, see this question for an isotropic material relationship. So this relationship I have just now explained. See this, all these formulas, 5 formulas I have told you, just you have to memorize it so that you can solve any of the question. Okay, next question we will see. A metal bar of length 100 mm is inserted between two rigid supports and its temperature is increased by 10 degree. If the coefficient of thermal expansion is 12 into 10 raised to minus 6 per degree centigrade and Young's modulus is 2 into 10 raised to 5 MPa, the stress in the bar is. So basically here we are supposed to find out the temperature stress, right? So temperature stress, suppose your metal bar of length 100 mm. So this is your metal bar. Its length L is equal to 100 mm they have given, right? Then is inserted between two rigid supports. Rigid supports means both the ends are fixed. This is A, this is B. They are, so basically when it will be heated, there will be thermal stresses because it is not free to expand. Okay, so thermal stresses will be induced in this rod. temperature is increased by 10 degrees centigrade. So delta T is 10 degrees centigrade. We are increasing the temperature. Okay, now what they have given, coefficient of thermal expansion. They have, it is alpha, right? 12 into 10 raised to minus 6 per degree centigrade. And Young's modulus, it is represented by E, that is 2 into 10 raised to 5 MPa. Okay, they have given in Pascal. We know that Pascal, see, 1 Pascal is equal to 1 Newton per meter square basically. This conversion you have to remember. Okay, but at present no need. Okay, so now we have to find out temperature stresses. So temperature stress, we should know this direct formula, that is E alpha T. So that is E 2 into 10 raised to 5 into alpha, they have given 12 into 10 raised to minus 6. Okay, and T means delta T. Okay, how much the temperature has increased, so that is 10. So 10 raised to 5, 10 raised to minus 6 cut, so 2 into 12, it will be 24 MPa. So directly you can get this answer. Is it clear? Okay, then next is this question, last question you can see over here. A rigid bar is suspended by 3 rods made of the same material. The area and length of the central rod, so they have given 3 rods and area and length are also different, so 3A and L respectively, while that of the 2 outer rods are 2A and 2L respectively. If downward force of 50 kilonewton is applied to the rigid bar, okay, remember this rigid bar, whenever they are giving this term rigid bar, it means that its own deflection will be 0. It is totally rigid. The forces in the central and each of the outer rod will be, okay, so basically we are supposed to find out the forces. Now let's draw this figure, how it looks, so that see, again let me see the question. A rigid bar is suspended by 3 rods, 3A and L and 2A and 2L, 50 kilonewton central portion. Okay, so here I am drawing this. Okay, so suppose this is my rigid bar, and some load is attached over here, that is they have given 50 kilonewton. Now the central is your L is less and 2L is more, so it will be like this. Okay, this here. Now you can see that the cross section area is 2A and 2L. Here also it is 2A and 2L. So length is 2L. So double the length of this central portion. This is, but here cross section area is more. So cross section area is 3A, but the length is half of this length. Okay, and this is your rigid bar. Rigid bar means it will not deflect. It will remain straight only. Either it will go up or it will come down, but it will remain in a horizontal position only. Okay, so now what happens when your load is coming from and load is in downward direction? So this, because of this rigid bar, there will be some tension in this. Suppose I am calling it as force in here P1, P2, P3. Okay, so forces in first bar is P1, so for second is P2 and P3. Now due to symmetry, can I say P1 is equal to P3? Okay, P1 is equal to P3. I can say, because you can see here it is 2A, 2L, here also 2A and 2L. Okay, so by symmetry you can easily write this equation. This is one important condition. If I am drawing free body diagram also, I can draw like this, that this is 50 kilonewton and here I am having 3 reactions, P1, P2, P3. So basically as both are if I am applying equilibrium condition sigma Fy is equal to 0, so it will be P1 plus P2 plus P3 is equal to 50 kilonewton. Okay, now P1 is equal to P3, means can I write 2P1 plus P2 is equal to 50 kilonewton? Just mark this, it will be useful ahead. Okay, now see, P2 is your central load, central reaction. Okay, and this is your rigid bar. Okay, so what happens because of this rigid bar? So whatever deflection will be there, actual deflection because of this load, that deflection will be in these rods. Okay, this first number rod, this is second rod and third rod, so there will be some deflection, but because of its rigidity, the deflection, remember one thing, because of rigid bar, the deflection in each rod will be equal. Okay, so deflection in each rod will be equal. I told you earlier that this rod, this bar will remain horizontal only. It will go up or down according to the load, but it will not deflect. Okay, so deflection will be seen in this rods 1, 2 and 3. Okay, now we know that axial deformation formula delta is equal to PL upon AE. This formula we know. So whenever there is any axial load, either tension or compression, okay, suppose this is my L length and this is P, so the delta will be, extension will be PL upon AE. Okay, so now just I will substitute the formula, because see, the delta is same for both the forces P1 or P2. So let's write P1 L. So for this L it is 2L A. So here it will be 2A and E. So material is same, they have given nothing about material. This is P2. So P2 L, it is L only upon AE, but A is your 3A and E. Now AE is cancelled, 2 is cancelled. Okay, L cancel. So basically it will be 3P1 is equal to P2. Okay, now just substitute this equation number 2 in equation number 1. So P2, so it will be 2P1 plus 3P1 is equal to 50. So basically P1 is equal to 5P1 is 50. So P1 is equal to 10 kilonewton, and P2 you will get how much? P2 you will get 3 into 10, 30 kilonewton. Okay, so P1 P2 obviously, and we know that P3 is also how much? 10 kilonewton only, because P1 and P3 are equal. Okay, so we have got all the values P1, P2 and P3. So here what will be the answer? Answer will be C, 30 kilonewton and 10 kilonewton. Okay, thank you very much.